In this lesson, we're going to find out how to solve a quadratic equation by using factoring. To start with, we need to think about what we know about quadratic functions and visualize them, because there's a very helpful thing to recognize. I've drawn some quadratic functions that I labeled A, B, and I should also label C here. And they have different properties. Quadratic function A has no x-intercepts, which are also called zeros. Quadratic function B has one x-intercept, and quadratic function C has two x-intercepts, or two zeros. Now, we can think about equations as being just like functions with a y value of 0. So this visualization is helping me think about the quadratic equation. If I have no x-intercepts, y doesn't equal 0, the equation would have no solution. If I have one intercept where y equals 0, then I must have one solution to a corresponding equation, and this x value would be that solution. If I cross the x-axis in two places and have two x-intercepts, or two zeros, where y is 0, which is just like what the equation looks like, then these correspond to the two x values that are my roots, or solutions. Now, a general form of a quadratic equation is ax squared bx and c, which we've seen, equals 0 for an equation, as opposed to y. You can see the reference to y equals 0. Now, if f of x is a quadratic function, and there's a value c that is a real root, real numbers, a real root of f of x, then all of these statements are true. X equals c is called a 0 of the function f of x. X equals c is a root of f of x equals 0. X equals c is a solution of f of x equals 0. A root or a solution are the same thing. Another thing that I know is that x minus c is a factor of the equation f of x equals 0. And furthermore, c comma 0, so if the x value is the value c, then this is the x-intercept of y equals f of x. You may want to pause and reflect on those and look at the graphs up above again. Another thing that we are going to take advantage of is something referred to as the zero product rule. If I have some value multiplied by some other value, and 0 is the result, then one of those values must be 0. The product that leads to 0 must have a 0 as one of the factors. We take advantage of that in a couple of examples here. So here is a quadratic. It's already in factored form. If two factors equal 0, that's like my a and b, that leads me to say 3x minus 5, one factor, must be 0, or 2x plus 1, the other factor, must be 0. This leads to 3x equals 5, and x equals 5 over 3. This other equation leads to 2x equals negative 1, and therefore x equals negative 1/2. These are my roots of this quadratic equation. It's not a function, it's an equation in this case, because it equals 0. I may have a quadratic equals 0 that's expanded. In that case, I'll try to factor it into two binomial factors. This one factors into x minus 4, x plus 1, leading to the result that x equals 4, or x equals negative 1. Again, my roots, or my solutions to the quadratic. Notice that quadratics can have two roots. Again, look up above at that graph. They can have 0, 1, or 2 roots. Our check would be to substitute roots into the equation and check for a true statement, like 5 equals 5, or 0 equals 0, or something like that. If I substitute 4 into this equation, you see that 4 squared is 16. 3 times 4 is 12. It's being subtracted, so now I have 4 as a result. And then if I subtract 4 more, I get 0 equals 0. That verifies that this is a root. Now, you may see other types of equations. They may not be in a factored form, which is really convenient. They may not be nice, tidy, general form quadratics. They may look like these two examples. In a case like this, we're dealing with a rational equation. You'll multiply by the LCD once you factor, if you need to, and once you reduce common factors, if there are any. Multiplying this term would lead to cancellation of the denominator with that factor. It would lead to the cancellation of this denominator with the factor. And it would lead to these factors multiplied together, and they're the same, so they're a binomial square. That's going to expand into x squared minus 6x plus 9. The left side expands into, or rather reduces into 2x minus 6. And you can see that I have an equation with a quadratic term. So in this scenario, we bring all of the terms to one side, isolate 0 on the other side, and then we try to factor, and they will be factorable in this lesson. So I'm looking for minus 3 and minus 5 as the values to substitute there, which leads to x equals 3, or 5, which are my two roots. If I have a quadratic equation that has a non-zero value here, I'm actually going to need to expand this first. Then I'm going to need to gather the terms to one side. And then I'm going to try to refactor. And I'm going to need a 3 times 1. And I need two negative values because the product is positive while the sum is negative. And in order to produce factors of 12, which are 1, 12, 2, 6, or 3, 4, that add to 20, I put a 6 here and a 2 here. And foiling, I see negative 18 minus 2. So 3x minus 2, x minus 6. This leads to 3x minus 2 equals 0. 3x equals 2, and therefore x equals 2/3. This leads to x equals 6. And those are my two roots. All right, one more thing. What if you're given a Jeopardy or backwards question? This is a favorite in math. We learn how to do something forward and then we learn how to undo it. So what if you're actually given the roots and we need to figure out the equation? Well, let's look back for a moment. When I see a root like 2/3, look at the factor that it came from. This 3 denominator matches this 3 coefficient, and this 2 numerator matches this other term. This is positive, and there was a negative sign. If I have a whole number like 6, it's just something like x minus 6. So let's take advantage of that and use that. If x equals 4 over 5, 5x equals 4, 5x minus 4 equals 0. This is one of my binomial factors. If x is negative 2/3, 3x is negative 2, and 3x plus 2 equals 0. There's my other binomial factor. So putting them together to make a quadratic is going to lead to 5x, erase my little mistake there, 5x minus 4 and 3x plus 2 equals 0. And expanding to get general form, 15x squared plus 10 minus 12, or minus 2x minus 8 equals 0. There you go. That's the basics of how to solve a quadratic equation by using factoring.